Good morning, everyone. Let's continue with the rest part of these slides. So, in the last slide, we talked about the relationship about the authors. Let's continue with the next one. So, this is the abstraction. You can find out I highlight some words or terms. So, I already uploaded the latest slides for this one. That means the slides contents are the same, but I made some notes. You can download as well. I will also send an announcement about this. Okay, this is abstract. That means you need a paper. We write as abstract. That means just the brief introduction about the contents in the paper. Okay, so let's read this one and understand. Also explain something to you. So this is about a deep learning survey. Of course, it will talk about what is deep learning, what is how to train a deep learning, and what is the applications of deep learning. So that's the important part. Okay. So deep learning definition. This is just introduction. What is deep learning? So this one we said deep learning allows computational models that are composed of multiple processing layers. So when we talk about deep, the most direct meaning is just like the number of layers are many, not like the previous shallow neural network. Just want to differentiate it from the previous one. In the past, we don't have ability to train a very deep neural network, just because we have to have a lot of have a quick training algorithm, and also we need to have a powerful computational compute. We have the powerful computational powerful computers. So this is the two main reasons. And also in the past we only have a small amount of data, so we cannot achieve much progress if we only have a small amount of data, just like I mentioned before. So the sample data is not large enough. Maybe when you deduct a model from this data, which is maybe is biased, the model it also has a limited capacity when we use it to test on testing data set. So this is the main reason. Okay, so that means first one, we need to know, okay, deep learning usually it involves many layers. How many layers? It depends. Yeah, just for example, in the past, we only can handle maybe up to 5 layers. So if your network it has maybe 10 layers, 12 layers, or 20 layers, or several hundred layers, of course, usually we think this is a deep learning model. Okay, so that means it is still neural networks, but it has more layers and also have more changes. Of course, not only just adding the layers. Okay, later we explain. So to learn representations of data, so you can think about deep learning is a tool to represent data. So you may have a question, why we want to learn representations of data? Okay, just like when we learned something, for example, learn an animal, you will give it a definition, correct? Or when we explain something, we just use some words to explain it. So usually we said this is the features. So these intrinsic features will be used to differentiate it from others. So that means these are important things we need to use to characterize a object, a scene, or even a meaning of a language, a sentence, like these things. So we have to just abstract the most important features of data, and then we can utilize this one to classify, to recognize, and to detect. So this is the reason we can use it for image classification, and language recognition, and speech recognition, and voice recognition, and speech recognition, and so on. We can recognize the object for self-driving cars, or detect objects, and so on. So we have to extract features, but how to extract features in the past? And researchers, we said, is experts in that field, do it manually. So different experts will extract different type of features. The final thing is like this: maybe your features are better generally than other features, generally better than others. Okay, you can present this one, publish this result, and then people will think this is advanced. But people later find maybe these features only perform well in some type of data, still not good enough to handle some other type of data. So that means the generalizability of the method is usually limited, is not powerful enough. The most important thing is that when we design the feature, we have some bias in our experiences, correct? So different people, different researchers, they have different emphasis in their research directions. They may focus on maybe neural network, they may focus on support vector machine, they may focus on statistics learning, and then they also may have different experience in designing features. So this is the headache. So people found this this manually, the handcrafted. When we talk about this, is handcrafted features. They are limited in applications. So that means still we have a lot of room to handle when we apply the methods, the features we have designed in handling applications. For example, handling self-driving cars, voice recognition, and designing home robot, like those things. So it is a lot powerful enough, correct? But the good thing is that deep learning is a lot handcrafted feature. It is an automatic tool to extract feature. You don't need to design the features by yourself. You just feed the data into the network. The network will learn the features automatically. As long as you have a powerful network, as long as you have a large enough data set, you will be able to train a powerful model, and then it has a good enough generability in capacity in applying to a broad range of topics. So this is the amazing part about deep learning. Okay. So in the past, people use a handcrafted feature. Now, people use automatic ones. So we talk about this one. We refer to this method as end-to-end. So one end is your input. For example, you have neural network. One end, you feed the image into the neural network directly. Of course, usually because the input layer, the number of neurons are fixed. So you have to resize the original images accordingly. For example, you have 400 neurons in your first input layer. You have to resize your image in 20 by 20 units. Like that, we prefer a square image, okay, square size image. So that means you have 20 by 20. If you have 60 by 60, you need to down sampling. If you have 10 by 10, you need to up sampling. Correct? So just resizing the image first. Okay, and then in the other end of the network, you may want to perform classification, object detection, and the image recognition. That's fine, correct? The output is just the results. That's the amazing part, correct? For example, you want to perform image classification. Input is 20 by 20, means 400 pixels. So image is composed of pixels, correct? Just like our screen is resolution, means you divided the screen into how many number of pixels in row and how many numbers of pixels in column. Then multiply the number of rows and number of columns. That's your resolution, correct? For example, like 1076 and 7 by 768, correct? Like the preference resolution is like this. That means how many number of pixels in rows and in columns. So you get a square pixels. Okay, input this number of pixels into the network, and then in the end you want to classify. So the end will get a list of neurons. For example, the first neuron will be the apple, the second one will be orange, the third one will be banana, the fourth one will be pineapple. So, and then you will get a value. Okay, how much possibility to classify this image into pineapple? Okay, we get is 90%, and then all others added together is only 10%. Of course, you will just use maximum based voting, correct? For majority vote method. You classify this image into pineapple. So you already make it, correct? So that means one end is the original data, we call raw data. The other side will be the solution. That means it depends which problem you want to do. Okay. So this end-to-end method will have more flexibilities and also has make the problem easier, accessible to anybody. Even you don't have much experience, there's a lot of existing models already designed for related problems. You can use it directly, just like now how you use network to do a lot of business, correct? So it will be accessible. It's very convenient for everyday people. Everybody is easily to learn it, correct? Even kids will learn it without teaching. So this is using Apple, for example, cell phone and so on. So this is the design philosophy. Make it accessible to everybody. Okay. Okay, let's look at next one. So this method has dramatically, this is just like the performance we mentioned. After we have this good design, we find its achievement in industry, in scientific research, in every industry, not only like the high tech, maybe in transportation, for example, the traffic flow control. In medical science, we can use it to discover new drugs. We can use it to detect skin cancer, correct? So just take images and then we can recognize whether there's some disease. Okay, so in a lot of things you can read the paper and then they provide a list of applications. So have dramatically improved the state of art. I mentioned, okay, the first one is ImageNet in 2012. So based on that results, so they do the much better performance than all the previous handcrafted features, and then raise the attention from industry and scientific research and the practitioners. So all of the people just spend time in applying or in designing models into their own fields, and also find, oh, really they are working, they are better. Of course, maybe not all, but mostly. For example, at least in visual information processing and speech, like this, so text, voice, and two dimension or 3 dimension. For example, 2-dimension we set is images, 3-dimension we set is computer graphics, and also 4-dimension we set is video, correct? So in handling all type of things, they have achieved much better results than the past. That's why I strongly recommend you consider whether you want to be a part of AI industry, correct? Of course, you have advantages, correct? Because you are computer science majors. You have advantages in learning AI related things, especially you have the training here, correct? So this AI course, we covered this latest deep learning. It is also already already included in the latest edition of this Bible AI book. So of course, you need to consider whether this is a great opportunity for you to join this flow of maybe you can think it's bubble, but I don't think it will be bubble. It will be a trend. Okay, it will be a trend. Just like from the past, we use a computer, and then we have network, we have big data, we have AI. That seems like a trend. Nobody can prevent it from stopping, from termination. But just need to be careful. If we have time, we still will want to cover it. Use it for good list of people, for our humankind. Okay, this is the bottom line for us to learn, for me to teach. Okay, we want to make a good list to the people. Of course, I will trust you. Yeah, but we need to use rules, not only trust list. Okay. So we found it has achieved a lot of improvement in speech recognition, visual object detection, or recognition. So speech recognition, for example, what is speech recognition? So the typical thing is just like I'm speaking, I'm speaking, and then you can recognize it is me speaking. This is called a speaker recognition. And the other one is speech recognition. You can understand the meaning I'm saying, right? So even I have accents, even maybe I use different words to represent the same meaning. You need to understand the meaning. This is called speech recognition. And a simple one, maybe you can think about, okay, just can translate my vocal signals into words. Okay? So recognize each word. Okay, of course, you need to understand if you need to correct it. Maybe some word is not good. You need to think about in front and after they form a sentence. Seems this word is not an appropriate one. You should guess maybe it's another one. Okay? So this is speech recognition. Of course, there's another more broad area called natural language and processing. So we call it NLP. It also has a related library in the Python, in your PyTorch as well. So called NLP. So natural language processing or natural language understanding in our book also have this chapter. So in fact, this is also a very hot topic in the recent industry development, productive development. Just to let you know, for example, like Microsoft, Apple, Facebook, and Google, especially Google and Microsoft, they target on developing some robots, the home assistant, some robots to help people to manage their life. So of course, you need to understand the natural language. So they send a command, so get something for me, and then give me a brief idea what is need to do, what are the things need to do today, and then just recognize these things. Of course, you need to understand natural language, means a language spoken by people, by human. Okay, so very hot topic as well in the deep learning field, speech recognition, natural language understanding. And for these things are related to lot of things like surveillance, self-driving cars, and transportation. Like I mentioned, you can just based on the traffic flow to send the announcement to manage the traffic as well. We can just track the flow. We detect how many trucks, how many cars, and how many pedestrians, and so on. And based on this one, to give a value to the crowd list of the road, and then remind people to avoid or to follow, like this. And many other domains such as drug discovery, even we can do this. We can test. So sometimes we don't need to just really use the practical word. We can use the computer word. We can say it's virtual word to do something that will drastically improve the speed. This is and also the genomics, the relate to genes, human genes. Okay, so deep learning discovers intricate structures. So this is talk about why it is working. So that means it can handle complicated problems. In the past, we use support vector machine, we use statistics learning. Usually we can only handle not so complicated model. For example, linear model to fit and so on. If it's not linear, we transform from nonlinear to linear first, and then we use a linear model to fit it. If you have a curve, and then I transform it into a linear. Transform means we map data space, map that original data space into another feature space, which can get a linear relationship, and then we can use a linear model. For example, if a line, use a line, to sometimes the not line. Linear model means just like you have only like the way like x square plus y square and xy, like these things. You don't have some other things like the how to say, just like the order will be different. The order will be different. Maybe this is another story. Don't need to cover all these things first. So just really it's like just we can handle nonlinear relationships in linear, but must be do the mapping first. You need to map the data from nonlinear to linear space. So but deep learning can discover. We said discover is automatically discover, just like as long as you design the network and then you feed the data into it. If you have large enough data set, they can automatically learn the intricate features. So that means they can extract the features automatically to fit your lead. For example, you want to do an object detection, they will detect the features which can improve the object detection performance. If you want to do recognize what is the object of this image, what is the object inside of this image, they can do it automatically. This is the idea. Intricate means they can handle different levels of complexities. It can be easy. Of course, they will achieve comparable performance as previous models, because easy problem they can handle 100% accuracy. This one also comparable. And then but they can also handle more difficult problems and also have less bar for people. So everybody, even high school students, they can also utilize the existing models or design simple models to handle a lot of complicated problems which can only be handled by expert person in the past. So how they find this feature, we said is using training. Which training algorithm? We use the BP algorithm. In shorthand, it's BP, called back propagation. So back propagation, the method we have learned before. So basically, you feed the data into the network, we said this is the feed forward pass. Okay, so you based on activation function, you generate the output, you can calculate output. Okay, for each neural from input. Activation function means y equal to fx, f of x. You get x, of course, you can calculate the y, and then feed this y into the next layer, and then you get the new y, and then new y again till the end. But finally, you get an error. This error is the difference between what you want to have and what you have. This error will be used to calculate the weight adjustment, because finally model, what is the model? Means the structure of a neural network, the structure you designed. How many layers, how many neurons in each layer. And then finally, during the training, you need to decide the weights. How much contribution for this neural to that neural. For this one, you have to decide. You have to decide. So learning the weights are the target for the training. So we said this is a hyperparameter. Hyperparameter means it's not only one dimension, it is multiple dimension. So anyway, you need to decide all the parameters, which is unset. If it's unset, you must set, because after you train the model, everything is fixed, and then you can get a fixed value. You cannot get different values every time you test the model. So you must get only a unique value when we utilize a train model. So you have to train the model to get a trained model by setting all the parameters. We use the BP. So in fact, in this slide, the most difficult part and also most of the important part is this algorithm. You also need to implement a partial of this algorithm in your project 3, as I mentioned, explained to you. So the backward pass you need to implement. The forward part, maybe you also need to implement partially. For example, like how to define the activation function, it will be not so hard. It will be very easy. And then how to calculate the output for each layers, and then feed the data into next layer. Okay, that flow, data flow. That's why we have a TensorFlow. So just Google give this name just because it's like a flow the tensor. Tensor is like a high dimensional data. Flow the tensors across different layers of the network, and then you get a result which is still tensor. Because that's the result, multiple results in the multiple dimensions in the last layer. Okay. To indicate how a machine should change its internal parameters that are used. Internal parameters means the weights I mentioned before, that are used to compute the representation in each layer. So you have to decide the parameters, and then you can extract features. Later we'll explain in the next slides, maybe not this one. We'll know, okay, which type of feature you can extract. In that part, I will give you an introduction first. So you can extract a different type of levels of features. For example, an image. In the first layer, you may get edge information. Edge, like edge. We detect edge. And then after that, you get you combine edges, you get motifs, so small structures. And then third layer, you may get third internal layer, you get the combine motif, you get a structure, and then you combine structure, you get object, and then based on object, you understand the scene, the whole thing. Like office, you get different objects, and based on objects inside the scene, you can decide, okay, this is the office. because it has laptop and a desk and chair and a whiteboard and so on. It's something like an office, right? Or you have a lot of computers and a lot of screens, a lot of chairs, row by row. But if we differentiate this one from classroom, what is the difference? So there's a big whiteboard, and there's a projector, and there's maybe several whiteboards in different walls of different size. So you have to extract the features, okay, to represent the core part, the key features of the object. The object can be a scene, can be really only one object. Okay. So your target is just fix the parameters to get a trained model. After that, you can use this trained model to test, so you can predict the future. Okay, you can predict unknown things. So this is the reason why we want to utilize training data set to train a model, and then in the future we can use it as a tool. Okay, so you can deploy it and then do it automatically. Okay, you don't need to use people. You can use a computer. So this is the reason, okay? Automation is important. And the deep convolutional nets have brought about breakthroughs in processing images, video, speech, audio, whereas the recurrent nets, so this one already mentioned before, okay? So that means a breakthrough, not only a small improvement, it is a tremendous improvement in a lot of fields. So recurrent networks, so it is also covered in the book, in the chapter. So recurrent network will be handle sequential data, a sequence of data. Why we use recurrent network? Just because the order doesn't matter, okay? We don't differentiate one by one. We need to differentiate all together. Like I'm saying, if you only catch one word, you don't understand what I'm saying, okay? You must combine the words I'm saying together, and then you understand what I'm saying. So this one, you feed one word into the network, you also need to memorize this word, and then feed another word into the network, and then feed another one. Once you get all the words in this sentence, you can understand the meaning of this sentence. So recurrent network, we have this loop, okay? So that means you need to have a memorization ability. So that means later we have the long short-term memory, okay? LST, long LSTM. I think it's maybe like that way. Later we talk about. Okay. So that will just have the capacity for memorization. Okay. So it will be useful for those type of sequential data. Okay, like text and speech. Okay, let's continue for the contents. So this abstraction, I think, will be good for you to have an overall idea of this field. Okay, so even you don't go to the details, you already know. Okay, well, this is your cake. This is your interest. Okay, let's continue. So deep learning. In this part, this is just like a brief introduction about deep learning. We talk about its definition, its applied domains, its mechanism, and the different type of networks. So CNN will be the most important part, also most successful part. And the next one may be the recurrent network, and the next one is the adversarial network. We may have no time to cover, but already mentioned several times the generative network. Okay. So mechanism basically is about its how it works, how it is trained. Okay, how it is tested. Okay, it is want to simulate our neural network. That's why it's called artificial neural networks, but it has some advantages. Okay, We don't want to simulate it in a biological way, it in a functionality way, okay? Function level. Okay, so we talk about first, it's applying the domain. So it has been used in speech recognition. For example, based on speech, you think out each words, okay, and then we can do captioning, okay? Just like these videos, I use user, and then maybe when I released the slides, the instructive videos, the captioning is still not available. But after maybe 1 hour or 2 hours, they will finish the processing, and then you can find the captioning, okay? They will recognize my speaking and then translate it into words, okay? Speech recognition. And the next one is visual object recognition. This is easy to understand. Just want to recognize the object in images, okay, or in a video. So like these things, we have a lot of images available online. We can recognize even video, okay, like YouTube. YouTube, it has a lot of videos, but in fact videos is also a sequence of images. You can also detect events in the video, okay? Video events detection, and also you can understand the human activities in the videos, like these things, okay? It also, video processing is also a important topic, hot topic in the related area, okay? In applying the deep learning in handling visual data, okay? Or object detection, still in the images, in this visual information, visual data, you can detect, okay, what is the person, okay? Face detection, or in this one you can also do face recognition. So what's the difference between recognition and the detection? Recognition, you want to know what it is. Detection, you just want to detect it out from the background. Okay, you detect this is the face. I want to detect face. This is the object. You find the boundary of the object. Recognition, you want to know what is the category of this object. Okay, this is apple. This is pineapple. You want to recognize it. Recognize it, just like recognize the people. Okay, this is Henry, this is John, and so on. This is, you need to differentiate from other, okay? That's the recognition. Okay, and also can be used in the drug discovery, predict drug activity, also in the gene, okay? Gene industry is also very hot topic. You can use the gene, okay, to predict the disease as well. The potential disease will be impacted by the person. Okay? The person will be impacted. So that means the possible disease a person may have based on the gene, and also something other application. Gene is also very important. Genes are also important to biology. Okay? Biology is also important branch in the modern scientific research. And then let's look at these pictures. For example, we said it's visual information, text, language, like this media, okay? Medias, and the speech and audio, and gene expression, and the product recommendation every day. Okay? You are using, we are very familiar with this thing. Okay? So you find the recommendations always. You visiting Amazon, eBay, and so on. Why? Just because of or Netflix. Just they recognize your preferred records, and then recognize these things. They can recommend the similar things to you. They record your history, okay? Your survey history, and also relational data. Okay, for example, like this social media, okay? Social media network. So we can find some information based on this network. Okay, which person are the V's, the big V's, the leaders. We find the leaders. In fact, I also collaborate with another, Miss Tom Rachel, in just doing the Arab leaders recognition, Arabic leaders recognition. So you can use the social media and then identify the leaders in maybe politics, maybe in religions, maybe in some other things as well in life. So you can recognize based on the social media, discover some information based on the network, because overall you can think about this is still a graph. Is a graph, and then you can, in fact, now there's a network called graph neural networks. So that means they want to develop algorithms to process graphs. Okay, graphs like these ones. So it's a structure, not like the previous image one. It's something like it's how many lines, and is at least it's like an angular image. But this one is a structure, it's a graph. So they based on the vertices and the connections, means edges. They want to explore the information from it. That will be a totally different story. And also climate change as well. I also collaborate with another professor in the GCRL. In the UCM, we have a Gulf Coast Research Library in the Ocean Spring. So we are learning what is the most decisive, most important, or we call it's the most significant vectors that will change the wet level of the wetland, the wetland loss. For example, in Mississippi, in Louisiana, there's a lot of wetlands, and then what's the contributing vectors for those wetland loss? Because wetland loss will impact the sea levels, and of course it's the cause of sea levels, and also we change the environment. We change the environment because you lose the wetland, and then it will approach our mainland. For example, like I saw the news for the Miami. Many places will be in the sea after maybe 30 years. So till 2050, maybe many houses will be in the below the sea level. If like that, okay. So people need to prepare for. This is just because of the sea level, the climate change, the ices are disappearing in the in the south pole of our Earth. So we need to care about the climate change as well. Yeah, we have the impact. We can see the impact every day. Okay. And also geologic, we do have geography and geology are different. So geologic data. So this is just talk about the Earth, and geography is on side. It's on the top of the Earth. That's geography. Okay, we can understand the earthquake and so on, like these things. So a lot, because it's also large amount of data. You haven't. Yeah, I have taught big data. In fact, we put a lot of sensors. We have a network of sensors to detect the movement of our Earth, and then based on this movement, you collect a lot of data, really big data, and then you need to estimate the earthquakes. Okay, as well. So how to utilize these things to predict earthquake or disasters? That will be important. Okay, like the California, we have the Sandra's earthquake data line, okay, from maybe California till Seattle, okay, till Washington State. So yeah, that's important thing, okay, for everybody. Okay, let's continue for the next. And this one, in fact, I already mentioned it before. So that means in the past we used to handcrafted feature, but now we use end-to-end. For example, this show data method. In the past we follow this way. Now we follow this way. End-to-end input, and then this is still traditional one. Okay, and then in the next slides I will put these two together. You'll find their difference. So let's look at, for example, you perform handcraft feature like this way: low level sensing, pre-processing, feature extraction, feature selection, inference, prediction, and recognition. You can find, for example, you use radar, you detect the images, you have satellite images, you have, or you can just use a camera, and anyway you use the sensors, okay? You get an image because the camera is just receive lights and then project the signal into digital way, or using in the past we use the different materials. We get get that one, and then like tapes, like those one. So anyway, you get an image based on the sensors, and then you do pre-processing, means you do the noise remover, or you just remove some outliers and so on. Or you do image enhancement. For example, the quality is not good, you enhance it, make it have better brightness and differentiation, cut. So pre-processing, this is anyway, this is about you can pre-process the data, cut. You can also do if it's a lot of visual information, you can do data cleaning. So just outliers, single out all the outliers, means that's not good data. You need to detect it. So pre-processing the data. After that, you try the features. You can think about it, this is like a data compression. So originally you have large amount of data. Now you want to condense it to get a small amount of data. You have only a visual factor. For example, initially you have 200 by 200. Now you only get 10 dimensional data. You get only feature which has only 10 dimensions, and then use this feature to do the classification, object detection, and so on. And then you can also perform feature selection. So that means you can try them a lot of features, but you want to delete the features which are not contributing to the problem. For example, detection, classification, and so on. You want to select the most important features that are beneficial for your problem. So you have a feature selection. And after you select the features, you perform the recognition. You can use a classifier. You can use some existing model and then recognize the object. Okay. So for this part, there's another word called dimensionality reduction. For example, you got 20 dimensions, but in fact maybe there's some redundancy. One feature is relying on another feature, so in fact there's a cause-effect relationship. So this is, for example, they are related. For example, like the date of birth and the age. In fact, they are dependent to each other, on each other. If you know the current time, you will know the current time and the age of the person. You know the date of birth, year of birth. Vice versa. You know the year of birth. You know the current year. You can know the age of the person. So you need to delete that redundancy. So that's called a dimensionality reduced dimension, dimensionality reduction. Okay, and after that you can perform last one you predict. So like this example, so input is the image, we represent features, we may pre-process the image as well, and then we get a learning algorithm. So that means we feed these features into a learning algorithm, we can learn the input categories. For example, okay, this is a motorcycle. For example, here we list several features like the very popular ones in the preferred handcraft features. One is called shift. Shift is a scale invariant feature transform. That means doesn't depending on the scale of the image and the object size of the image. The other one is the histogram of gradient oriented gradients. In fact, for both these two features, we used before as well, because they are maybe the most powerful features till maybe 2010. Okay, people use it for a lot. So in fact, there's another one, maybe shape context. I also use it similar feature like this one. So the idea is just like they measure the dimensions, directions, orientations, and then they use a circle to represent the distribution of that orientations, and then divide the circle into sectors, and then in each sector how much percentage of each orientations, that means the orientations, the percentage of the orientations fall in this section, and then use this percentage and also the positions of the sections, you can construct a histogram, because you can flatten it, you get a histogram. So you put the first one as from the first histogram, and then what's the percentage, second sector, what is the percentage. So you get a histogram of oriented gradients. So this one of course is a gradient. You can also use the direction. So that's the shape context. Okay, so but this one you can find it is working in some fields but not working in all. That's the problem. Okay, so let's look at deep learning. In fact, is a type of representation learning. That means it can automatically learn a representation from the raw data. For example, like this one, you get a pixels, and then next layer you can extract edge information, and then you can combining edge information, you get the object parts, and then you combine the parts, you get the objects. Is it good? You detect the edges, for example, like edges, this is like contours, and our eyes, and our nose. These edges, they are different important features, and then we combine this edge. For example, like an eye, we can have the upper and the lower, and then we combine, we get eyes contour. Okay, we get the parts, and then we get combine the parts together, we combine these object parts together, we get an object. Okay, this is a face object, so we can detect objects. Okay, this is the idea. That means you can also output the results of different layers. For example, you want to get edge information. Okay, the layers, you can output each layer's output. For example, you get this neural in this layer, first layer, you want to get edge information, you can output just print, you can extract the output of any layer. Okay, that's great. And then this is we said this is a representation learning. So a machine is fed with raw data, and then we can automatically discover representations. So you don't need to design the features beforehand. You just feed the image into the network automatically, and then it will learn. Of course, you need to develop learning algorithms, but now you have PyTorch, the traditional learning algorithms. Of course, we already provided that learning algorithm in the lecture 12. So we may have different optimization algorithms, and we can choose. But anyway, we have PyTorch, we have TensorFlow, we have a lot of platforms for you to develop algorithms. So you don't need to develop those training algorithms from scratch. You just need to select which algorithm you need to design, okay? Which algorithm are good fit for your problem. Okay, so that means of course in your PS3 we want to enhance your understanding about neural networks. So I ask you to implement that training algorithm by yourself. In fact, all those things have been implemented in our PyTorch and Keras and TensorFlow, different deep learning platforms, okay, computation platforms. And also in I think Microsoft also have one called CNTK, okay. I think it's called toolkits, cat CNTK, because I ever went to New Orleans to attend a Triple AI conference. They offer a tutorial about this one. C is what? N is network, maybe convolutional neural network, maybe, and then toolkits, CNTK. Okay, so different companies, they have different tools, but anyway, for you can choose one. I will strongly recommend you use PyTorch because it's easier for you. Okay, it's the top level, is wrap up to the highest level. You just use it directly, just like you are using operating system APIs. You can use printf rather than go to the lower level. Okay? Use a high level. Use a modern program language. That's better, easier. Okay, deep learning models are representation learning methods with multiple levels of representation. This is easy to understand. So it can extract a representation from the raw data, and then they have different level of layers. Each level represents different type of features of the raw data. It is simple, but so it's very simple, but nonlinear models. Okay, so it's simple to design, but it's nonlinear model. That means it can represent nonlinear relationship. For example, from the image to an object class, that is nonlinear. Nonlinear means we can represent a class, for example, apple, using a lot of images. So this is not a linear, correct? You cannot find a single input to map to the single output. It's many to one. So it's not a one to one. One to one, we can think about the x to y. So linear relationship, like x squared plus x plus 1 is still linear because it's only one input, one output. But this is many input mapped to one output. All of these one are faces. We want to detect faces. Correct? So we can, with the composition of enough such transformations, so layers, activation functions, so transform the data from layer to layer. Okay, we can learn very complicated structures or functions, because you can think about the target for you. You just want to map from x to y, correct? You want to learn a function of f from x to y. Y is what? Category, or the boundary of the object. If you do detection, category means you do the classification or recognition. Okay, so x is what? X is your input, is your original images. Okay, we have some key aspect about this one. Is layers features are not designed by human engineers. It's automatically learned, not handcrafted. Okay, learn the features from data using a general purpose learning procedure. So we said it's a general purpose learning procedure, means this model maybe is general enough to handle a lot of problems. It doesn't depending on the domains. For example, for this object classification or detection, you can handle some subdomains. What means subdomain? For example, this one is subdomain, owning the face. But if you do the general one, means you want to detect all the objects, different objects like a cup, like books, like a desk, like chairs, right? Like all the objects in a scene. So this is a different type of objects. It's general. So they can handle specific domains. They can also handle general domains. So this is a general purpose. For this general purpose model, if you trained, you can also utilize it to handle the specific domain, specific purpose domain. You may just need to do some adjusted. We use a pre-trained model, and then we use fine-tuning. Fine-tuning, that means we change or adjust the weights of the network a little bit, and then we get a new model to accommodate this specific purpose problem. So that's the idea. Okay, we can use existing models because they already learned. We already learned this one from a large amount of data. They already handle a large number of categories. So if we want to handle your small number of categories, we can further improve the performance by do adjustment. You can train again on your training data, and then you get a better trained model, and then you test it on your own testing data set. You may achieve better performance than directly applying that general model on your testing data set. So this is the typical way when we use machine learning. We use deep learning models in handling our specific fields. Okay. So now we already develop a lot of model, like for example, just single out, give some examples. So we mentioned about before, we have lec11, and then we have ResNet, ResidueNet, we have the VGG, very big website, very big network. We may have some other one to handle the language processing. We may have some one used for object detection. We have YOLA, Y-O-L-A. Okay? We also have a RetinaNet, just simulate our retina, okay? RetinaNet. So people already develop a lot of networks there. So you can utilize those networks automatically, directly, and then change it to handle your own problem. Okay. So next one, we want to talk about these things. So the mechanism. So what is going on behind? So because we are majors, okay, besides learning how to use it, we also need to understand what is going on. So that means we can design by ourselves. We can change the model. We can do more improvement. So here we think about, for example, we have a lecture language, lecture images, and then we said this is called a window, okay, filter window. So we can use a window, and then we move the window line by line and row by row, and then based on this window we can calculate some features. So this we call the filtering, image filtering. For example, when we do the noise remover, we also apply this window-based filtering. We slide the window, okay, sliding window. So we move the window row by row and column by column, and then for each window we calculate the convolution. Okay, what is convolution? So this is an important concept. I may need to explain a little bit. So for example, we get a window. This is a window, and then for simplest it's 3 by 3. Okay, also 3 by 3. Okay, this is a image, and then we can design a filter. For example, the filter is like this way, the 5 minus 1 minus 1 minus 1 minus 1, for example. Okay, anyway, okay, and then we can move this window to here, so coincide with this part. So that means first one, we just like we move the filter into this way, and then initially this image has some pixels. For example, this is 100, this is 200, this is 150, and so on. Cut anyway, just like this. And then you can apply the convolution. What is convolution? Convolution means you do multiplication correspondingly. Okay. Okay, let's continue. Just now is the get up time. Okay, so I got up very early today. So that means the convolution is like this way. So you do the like this one. Good. So what's the idea? Convolution is like you have pixels. For example, image is I, and then ij, and then you have weight ij, and then you sum together. Right? This is I, this is j. So that means after that you get one value. Right? One value. This one value will be used to calculate the feature of here. So that means that for this window is 3 by 3. After you do the convolution, you only get one value. So after that, for this image, you slide the window, and then you get a smaller feature image. Okay? For example, you slide this window one by one. So from here, one to here, for example. So you get a feature for here. If you slide one to here, you get a feature for here. Okay? So that means you will remove the border. Okay? You only keep this one. So that means you calculate the features for this one. So filtering is also like this way. And the filtering, if you don't know how to get the border, okay, then you need to just like we said, we extend the in each side this border, and then you still can apply. You can still apply the filter and then calculate the value for here pixels. Okay, this is really about image processing, but convolution is an important concept. Just because we have a convolutional neural networks, so that means when we do the layer by layer data transform, we also perform convolution for layers. So we said we have a convolution layer. So in fact, we perform this way. We extract features and make the feature image smaller and smaller, and then we can get features for different levels. Okay. So this is the idea. Okay, this is idea. So in these slides, we talk about the convolutional CNN, okay? Convolutional neural networks. So it's about this one. So convolution. So you first do convolution and then do the ReLU. Okay? ReLU is rectified linear unit. That's the activation function. And then finally you got the categories. Okay. Okay, let's go back. So this is the basic idea. Okay, the basic idea about this thing, and so that means we can extract features. So we can represent. For example, this one we set based on this one, we can learn some basics. So you can think about this like a Fourier transform. Fourier transform, you can represent a signal using weighted combination of bases. So this is the basis. So it's like this one. So this image, this for example, you crop this window, you get this small window. This one is a combination of the pixels, like this way. Okay. So you can represent this window using a small concise representation. Cut is 0.8 of this one. This base is 536, and this one. So you just need to assign, use this vector, because you can fix the bases based on the order, and then use this one to represent, so on and so forth. So this is 3 examples. We have different representations to represent different image signal. Cut. So this is the idea. So similar way, for example, this is the basis. In fact, we can learn the basis here. What is the basis here? In fact, it's edges. Cut. Edges are bases. We combine edges, we get components. We combine components, we get objects. Cut. Okay, this is ideal. That means cars can be represented by these components. A component can be represented by this type of edges. Okay, this type of edges. So this is the idea how we can extract features layer by layer. Different layers represent different level of features. Okay, that's a smart idea. Okay, you can also get the features of different levels directly. Okay. For the audio, so preferred is image, 2 dimension. Audio is 1 dimension. Okay, 1 dimension. We can also do similar way. So just like this, we have bases represent the signal into as a combination of these basis signals. Okay. And then in fact, deep learning has achieved a lot of advances in different fields. You can read this one by one, and then in the paper, I also uploaded that paper as well. I will send an announcement to remind you of this, so you can refer to the reference in the end of the paper. So about these things: image recognition, speech recognition, many other domains like these things, and the natural language understanding like these things. Sentiment means emotion, question answering, QA, and also we can learn topics. For example, image cut, we can learn its topics like we mentioned before. Language translation, yeah, that's really useful. Translate language. So in the future, you don't need to bring a robot with you. You can use a cell phone. You can go any place of the world, and then you use a screen, use your screen, use your voice, use the voice or screen of the cell phone. You can understand everything. That's great, cat. Okay, this is the outline of the paper. So it will talk about supervised learning. We already know this idea. And the backpropagation. This is the main things we want to learn. How to do the training. And then we'll also talk about the CNN. Okay, not that CNN. Okay, that media. And the image understanding. That means we can use deep neural network, use deep learning to understand the image. So image understanding, low level is recognition, object detection, and classification. Once we know this one, we can understand the image as a whole. Okay? So we mentioned before, low level is computer graphics, and then after that image processing, and after that image understanding, computer vision. Okay? Computer vision is after image processing, computer vision, image understanding. Yeah. Distributed representations and the language processing. So this one is related to the recurrent network. So we'll talk about this one as well. And the future of deep learning. Of course, I want to mention this is in 2015. Many new advances after that. So this one didn't mention about the the generative network. So expand the generative adversarial network. Okay, again. And this one we already know, right? We don't need to repeat. So supervised learning, what is supervised learning? We just want to mention about the stochastic gradient descent method. So this is the meaning, the word we want to refer to the learning algorithms of deep learning. We said it's called a stochastic gradient descent. So in the past, we use gradient descent. Gradient descent is what? Is the one we have mentioned before. Use that gradient, right? And then we can calculate data. We can use the learning rate. We change the weight. And the stochastic means we divided the data into batches. We assume each batch follows the same distribution as the original training dataset. And then in each batch, we can perform the training. So we can update the weights more often than another way. So what's the meaning here? Let's look at. If you divided the original training data into 10 batches, in each batch, after you finish the training, you can get a weight adjustment. So you can update the weight already. You don't need to wait till you finish training, feeding all the data samples into the network to update the weights. Means you have only used 1/10 of the data. You already update the weights by one time. So once you finish all the data, you already update the weights for 10 times. So you can get a quicker training, right? Quicker training. So this is the idea. Okay, why stochastic? Because we have small sets gives a noise estimate. Noise estimate, that means still have a noisy, but it follows some normal distribution. So it's noise estimate of the average gradient over all examples. So that means based on this 1/10, you can estimate the adjustment already. So you can do update at first, and based on this updated model, you do the further finalization, kind of from coarse to fine optimization, and then you finalize it again. So just like you climb a hill, first one you get a car, you get a truck to help you to reach a mountain which can reach a maybe slope which can headed you to the peak of the mountain, and then you have some other tools, so you can quickly converge to the peak, to the best, to the optimal of the solution. You don't need to do inch by inch, right? So this is the idea. So we said stochastic. Stochastic means we divide the data into batches, and in each batch they follow a noise estimation distribution, right? Okay, others I think you can just read by yourself. It's not very new. So we want to mention in the past the handcrafted feature cannot distinguish wolf and semiot. So that means they are too close to each other, correct? They are both are white and very close to each other. Maybe this is just come from wolf. Yeah, you can try wolf and maybe dog, cat, hybrid. These two we get a semiot. But deep learning can distinguish one from each other. We can use it. So that means it has a more powerful capacity in differentiating minor differences between objects, between data among different categories of data. This is the amazing part. Okay, so next one. Next one is the main topic of this part. We want to learn the backpropagation algorithm. Okay, so I don't think we have enough time to cover all of them, but I will give you an initial idea anyway first. So backpropagation is not new. I want to let you know. In the past, we already have backpropagation, but we utilize this one for shallow network. So later we improve this backpropagation training algorithm to accommodate it to train deep neural networks. So we already achieved a good advancement, like we mentioned, stochastic gradient. In the past, we used gradient descent, and now we use stochastic gradient descent. Okay. So the key insight is that nothing more than a practical application of the chain rule for derivatives. What is the chain rule? Is here. I think you learned before, cat. So you have learned a partial derivative. Cat, partial derivative. For example, that delta y is round z, round y, delta y. Okay. For example, you have function which is z is equal to f of x and y. So z is not only related to x but also related to y. So you can only perform partial derivative rather than derivative. So that means you have a partial derivative. So that means what's the rate of change? If you change y, what will be the change of z? Right? So zeta means a small change of y. Zeta round zeta is a small change. Round means you perform the derivative applied on the function. You get this round z, round y. You perform that partial derivative. So delta z, how much change? If we change the y, you need to apply this rate of change. Correct? How fast? And then similarly for x, you also have this. You perform round y, round x. This is rate of change. If you change x, what a rate of change of y. And then if you really change that x, that small amount of change in x, you get a small amount of change in y. This is rate of change about changing x, how much change in y. Correct? Okay. So you can find here the basic idea is that so let's continue for the next. So that means you can find this delta z, delta y, delta x seems like what? X, y, z. Correct? So this is the relationship. You can find that this is x, y, and z. Is like the input hidden layer and the output is cut like this way. So that means you can backpropagate the result based on this method. So based on delta z, delta y, you can also calculate this one like this way. Delta z equal to round z, round y, round y, round x, round and delta x. Why we can do that? Because you can find z and x, they jump over y, but here you can just rebuild it, can reconstruct. So z about y, and then y about x. So you can reach x now. So z, round y, and then round y, round x. Okay? Z is a function of y, y is a function of x. So that means this is the idea for the backpropagation. You can, this is like an arrow, okay? The gradient or something. Anyway, you can transform the arrow from layer to layer, okay? From here to here, here to here. So that means if this is the arrow, you know it's backpropagated to the next one, and then you can also backpropagate to here. So even you don't backpropagate here, you already can calculate how much here, because you have this derivative already. This is just activation function, right? So this is the basic idea about the BP algorithm. We'll look at this one in detail maybe next week. So we first understand its rough idea. So that means we use the chain rule of derivatives. So we backpropagate the arrows from the bottom layers to the upper layer, okay? And then upper layer again. And then in the feed forward neural networks, so feed forward, that means the connection can only go to the layers in the front cannot go back. Okay? If recurrent neural network means it can go back. So we often use the nonlinear functions like these things. Okay. So this one talk about backpropagation to train. We also need to care about the typical activation functions. So we have the max z0. So this is easy cut. So just like the rectilinear, this is the ideal. So if it's less than z, less than 0 will be 0. If it's larger than 0, will be just the z itself, means the signal itself. So we give this one a new name called ReLU. So rectifier linear unit. Okay, so that means if it's linear, it will be equal to z, but it will be flipped. Cat will be flipped. Let's look at like this way. This is x, y, cat, if that is z. So if it's larger than 0, will be itself. If it's less than 0, will be 0. So this one called ReLU. Okay, ReLU. So this is 1. Okay, this is 1. Okay, one activation function. Okay, and then we have taunting z, and this one as well, like this. Okay, so this should be sigmoid, and taunting z, this taunting function. Okay, and then we talk about later advancement. For example, we do some more achievement in these papers. Revised around 2006 by unsupervised learning procedure with unlabeled data. So that means it can also be used to train for the unsupervised learning. And then CIFAR, we also use this one in our PS3. And later we have the CNN convolutional network. So ConvNet, CNN. It has been widely adopted by the computer vision community, like the lec11 1990. So this one should be the lec11 one, cut, and then this one, lec11 1998. Okay, some paper you can read. So this part we give an initial introduction, and then let's see whether we can finish it or not. Let's try. Okay. So we have a backpropagation, the key inside. Okay, let's look at the details about this algorithm again. So first one, we have a general idea about this BP algorithm. We said it's like this way. The derivative, in fact, we have another name called gradient. So that means the gradient is just like this. Just like this, we calculate gradient. We can utilize the activation function to calculate this gradient directly. So because this is an input-output relationship, so it's only depending on the activation function. So we already know the activation max, ReLU, and so on, kind of like these things, and the sigmoid, and so on. So you can calculate that one easily. So it can be implemented pre-computed in advance. So the derivative of the objective with respect to the input of a module. So this means the input of module means here. Okay, so in fact here we said the module is 1 euro. Okay, can be calculated by working backwards from the gradient with respect to the output of that module or the inputs of the subsequent module. So this means what? So for example, this is backward, that means this is last layer, this is last about 1, this is last about 2. Okay, so for this one, the gradient, okay, the derivative the derivative of this one, that means we want to know the round z, round x. We don't know how to calculate this one, but we can just use this one as a bridge. Okay, use this one the bridge. So round z, round x we don't know. We can utilize first round z to round y, and then round y to round x. The reason is just because we deduce this one here. So we calculated the relationship between delta z and delta x in fact is just this relationship. This is the rate of change between delta x and delta y. Okay? Delta x over delta y, delta z over delta x is equal to this one. Okay, so if we use the limit on both sides, that one will be the round z, round x. So just the rate of change. So this one we deduce this one by working backward. So that means from the last layer we go back, right? So we already know this relationship. We can calculate because this input output we know. This input output we know based on the activation function of each of these two. So that's why we said the derivative of the objective round z, round x, this one and this one, with respect to the input of a module can be computed by working backward. Go back, right? From the gradient with respect to the output of the module. Okay, so let's look at the chain rule of a derivative. Tells us how two small effects. This one we already mentioned before. Okay, two small effects. That means a small change of x on y. Small change of x on y. That means x on y, round y, round x, okay, round y, round x. That and that of y on z, round z, round y. That means small change. This is the idea. Are composed. A small change delta x in x, a small change delta x in x gets transformed first into a small change delta y, that's here, by getting multiplied by round y, round x, that's here. So this is because we know the relationship between these two, okay? So the data flow is from here to here. So this is input for this one, this is output. So we know. Okay, based on this relationship y and x, we know this one. So that is by this round y, round x, that is the definition of partial derivative. This is the gradient. Okay. Similarly, so here, so this y and x has this round y, round x relationship. Similarly, z and y has this relationship as well. Okay. Similarly, the change delta y creates a change of delta z in z. Substituting one equation into the other gives the chain rule of derivative how delta x gets turned into delta z. That means how can we reach delta z from delta x? There is a rate of change by doing this one. How to do that? You substitute, okay? Because this one delta z is this one delta y, so you substitute this one to here, okay? So this right part to here. So you get a round z, round y, round y, round x, delta x here. Okay. So substituting one equation into the other gives the chain rule of derivative how delta x gets turned into delta z through multiplication by the product of round y, round x, and round z, round x. That's here. It also works when x and y and z, x, y, z are vectors. So this is only we talk about one dimension. In fact, it may involve a lot of parameters. Okay, not parameters, lot of input, output. Okay, so that's the matter. So if there are vectors, we call this derivative are Jacobian matrices. So the gradient will become Jacobian matrices. So in fact, you can think about each column is a digit is a gradient with respect to one variable. You have multiple columns, and then you have a Jacobian matrix. Okay, just based on this method, this backpropagation method, we can backpropagate the arrows from the last layer to all the layers in front, on the top, and then we can calculate the weights, because based on distributive gradient, if we know the gradient, then we know how to adjust the weights. We follow that method. We choose a rate of change by choosing a learning rate. Okay, how fast? Because if you get this one, you don't need to use this one in the full. You can use a portion of it. This portion is decided by the learning rate. You don't want to miss the optimized goal. You want to choose it in a careful way. Do not bumping back and forth. For example, if you have a value, if you bump and forth, you may bump out of the value. You miss this smallest value, so you may need to bumping slowly, and then you can reach the bottom of the valley. You find the smallest one. This is the idea. Okay, in the next week, because we want to use up our time, in the next week we'll continue with this backpropagation. I believe based on this detailed introduction of the deep learning and the idea of backpropagation, for the following slides, even if you prefer, you can read it by yourself, and then if you move faster than our progress for PS3, you can just continue by learning. I believe you have a solid background now. So later we talk about continue feed forward and backward, two passes, each one what is going on there. Okay, I think that's all for this week, and then see you next week. Let me know if you have any question about the deep learning part and also about the PS3. Okay, thank you, bye bye.